So let's get started with our experiment. Here I've got a gallon jar, like you might buy pickles in, and I've got a 7.5 ounce can of ginger ale, Schweppes brand, great stuff, if you like ginger ale. And here I've got some molten gallium, and we've messed around with gallium here before, but we know that the melting point of this is 85.6 degrees, and right now I had to heat it up because it's not melting in the classroom today, obviously. So we're going to have a little fun with some gallium today. Gallium and aluminum don't get along very nicely, and as you know, this pop can here is made of aluminum. So let's take a look at some of the science behind this, why gallium and aluminum don't get along very nicely, and what actually might happen if we put the two together. So aluminum as a metal is made up of atoms that are very tightly bonded together, and I use these circles here to represent atoms. But aluminum has a crystal or crystalline structure. And so we have these individual crystals that are tightly bonded together, but in between these crystals we have bonds that are not as tightly bonded together. And when we introduce gallium to aluminum, because gallium is a liquid metal, that gallium physically enters the space between those crystals or grains. This is not a chemical reaction. This is the gallium simply physically entering the crystalline structure of the aluminum. And what that does is it weakens the bonds in between, and it makes the aluminum become super brittle so you can crush it just like potato chips. So what would be super interesting is if we could put gallium on the outside of an aluminum pop can and have that pop can degrade or become what we call embrittled, and see what happens. So back to our experiment here. We have the aluminum pop can here of ginger ale, and I think we should shake it because shaking pop cans is always a good idea. Alright, I think that's sufficiently shaken. And we're going to set it upside down here. And we're going to take a little bit of gallium and we're going to dump it on top. And then I'm going to put this jar over top just to keep the classroom a little bit safer. So after putting gallium on the bottom of the can and waiting for like a half an hour or longer, nothing happened. So I'm hypothesizing that the bottom of the can is too thick, and we're going to try the side of the can. So I sanded down the side of the can to get rid of the paint and the polish, and we're going to try putting some gallium on that section and see if that works better. Classroom safety chamber. And we'll just prop this so it doesn't roll too badly. We should shake things just to make sure we still have good pressure here, because that's just a good idea. All right. Insert can, pour gallium, gallium runs off the side, rub gallium into the top, rub more gallium in. This is hazardous. Alright, that worked, and that officially scared me. So let's take a look at the damages and see what happened. Sorry about the ginger ale, everyone. Alright, so here's our can, and gallium and aluminum don't get along super nicely. You can see this can is pretty much a goner. Just for the sake of official records, they always say, don't try this at home.